Mr. Brown, you're muted.
Cool, it's definitely the Friday before spring break. Let me try that again. So I'm just doing two problems today. Looking at this, we are going to go ahead and try this one. To review from yesterday, we're going to start off by first we know separating and then integrating. And that's always the first two steps for these problems. After those two steps, we can kind of branch out and do different things. Sometimes we're just asking for a general solution and we're like, hey, this is a general solution, we're good to go. Sometimes we have to plug in an initial condition to find a particular solution. And then sometimes we have to solve for y and sometimes we don't. So you always want to look at the phrasing just to make sure you understand what you need to do. And again, when I see this one, that phrase particular means we are going to have to solve for c. This statement means that we are going to have to put our answer in the form of y equals some function. And first step is always going to be to kind of separate your variables. So we have dy dx is equal to x times y plus 2y. If you're separating your variables, what might be the first thing you try to do algebraically? Factor out the y. So if you're separating them, you probably want to get that y by itself. So we have dy dx is equal to y times x plus 2. So just factoring out that y. And then now you can separate. So I'm going to basically divide by y and then multiply by x. So you're going to end up with 1 over y. dy is equal to x plus 2 dx. So I've done the first step. I have separated everything. Second step, now I just want to integrate both sides. So I have the integral of 1 over y and the integral of x plus 2. 1 over y is going to become what? Natural log. So that's your natural log rule of the absolute value of y technically. And that's equal to, would be 1/2 of x squared plus 2x. And then please don't forget that constant of integration. And then two options. You could solve for y now. Me personally, I like plugging in the initial condition first before solving for y. I just find it normally has fewer algebraic steps if you do it that way. So if we're saying that the point is 2, 1, then plugging that in, I have the natural log of 1 is equal to 1/2 of 2 squared plus 2 times 2 plus c. And then that would be something that I can solve pretty easily. Should know this, the natural log of 1 is equal to 0. So we have 0 is equal to 1/2 of 4. So that's going to be 2 plus 4 plus c, giving me c is equal to -6. Where are we going to use that? I'm going to go back to where I first integrated and combine that answer with the constant that I had. And so now I have the equation, the natural log of the absolute value of y is equal to 1/2 of x squared plus 2x plus c, or minus that 6. Now, if this question did not have that y equals f of x, then we wouldn't be able to stop there. Like that would be the equation, that would be a particular solution. This problem, though, I guess unfortunately for us, had y is equal to f of x. I guess I should say unfortunately for us since I wrote it. So, but we are going to go ahead and solve for y equals. So maybe we need to remind ourselves, we right now have the natural log of y. What do I need to do to both sides of this equation to get the y by itself? Base e. So we're going to base e both sides. So I'm going to have base e, and making sure we're clear that like that whole right-hand side is now in the exponent. You're not base e-ing each individual term. You can't do that across plus or minus signs. But we are going to base e that entire right-hand side. So I do have the absolute value of y is equal to e raised to all of this. And then we need to kind of think about how we can answer it. Now, normally, when we see that absolute value, we want to get rid of it. What does an absolute value do to a number? Makes it positive. So you want to think to yourself, well, before you make it positive, what could have that number been? It could have been negative, or it could have already been positive. So if you drop off an absolute value mathematically, what you're basically saying is, hey, this y was either positive or negative, and so I drop it off, but kind of put a plus or minus on the other side. Almost there. We know by that plus or minus, same thing that shows up with the square root, that's currently not a function that would fail the vertical line test. We need to pick, hey, is this the positive one, or hey, is it the minus one? How do we tell which one it is? We just go back up to the initial condition. We see that this is a positive y. So I'm going to choose the positive option for my answer. So your final answer is going to be y is equal to e, again, technically positive e, to the 1/2 x squared plus 2x minus 6. How can we change that? Like instead of my initial condition was say at like 2 comma negative 1, then I would have chosen the negative e raised to all of that. And of course, it is also perfectly fine if you jump straight from this line right here down to the final answer, right? Because I think many of you could look at this and know, yes, I need to base e both sides. Yes, I need to drop off that absolute value. I know the y is positive, so let me just choose the positive instead of the minus 1. Any questions on that problem? All right, one more. I want to do at least one more that had some logarithms. This one has a little bit more logarithms than that one. But we do often see logarithms for these problems just because of how they work out. So looking at this one, I have find the particular solution. So we are going to have to solve for c. Given that y of 0 is equal to 1, and x is positive and y is positive, and then we have this differential equation, 2xy prime plus 9y prime plus y is equal to 0. So this one will have a little bit more algebra at the front end of it, of like trying to separate our variables. Do want to remind ourselves that when we see y prime, clearly that's the same thing as dy dx. And we know that when we're separating our variables, we will have to write it as dy dx in order to separate it correctly. One thing that can be kind of confusing for some students in that there are different routes you can take to separate like your variables. Like some people get certain things on one side, others get certain things on the other side. For me personally, when I look at this problem, I notice that we have two terms with a y prime in it. And again, that's going to be the dy dx. So for me, it's going to be easier if I just kind of keep those together on the same side of the equal sign. So I might have something like 2xy prime plus 9y prime is equal to moving that y term to the other side as negative y. Why would I do that? Those two terms on the left-hand side now both have y prime in them. What can I do with that y prime? Factor it out. I'm going to do two steps at once. Yes, I'm going to factor it out, but I'm also going to go back and write it as dy dx. So factoring it out, we're going to pull out that y prime. And so I have 2x plus 9 is equal to that negative y. And again, that dy dx came from factoring out the y prime. And now we just want to think about separating the variables. Now for me personally, I like putting all of my y's on the left, x's on the right. So if I'm looking at this one, I might first multiply by the dx. And some of you could probably do this in one step instead of the two steps I'm doing it in. But when you multiply by the dx, that puts the dx on the other side. And then if you're looking at how you can kind of separate them, you basically need to divide both sides by the y, and then divide both sides by the 2x plus 9. So how I'm going to look at this, we'll have 1 over y dy is equal to negative 1 over 2x plus 9 dx. So I divided by y, divided by the 2x plus 9. Again, that's not the only thing you could have gotten. The other difference is you might have had that negative on the other side. Like if you worked it out and got negative 1 over y is equal to positive 1 over 2x plus 9, that would be the same thing algebraically. So this one did require a little bit more work getting to that first step. But now we can go ahead and kind of continue it with like the calculus part. So we have separated our variables. Once we separate them, what comes next? Integrate. So I'm going to go ahead and take the integral of both sides. That left-hand side is 1 over y. What's going to be the integral of 1 over y? ln of the natural log of y is equal to, looking at this other side, I have a negative that's going to come across. What integration rule do I need to remind myself about when I'm doing negative 1 over 2x plus 9? U sub. So we have this denominator is u is equal to 2x plus 9. So u prime would be equal to 2, which is going to put a 1/2 on the outside. And I can go back and do my rule. The natural log of 2x plus 9, don't forget your c. Some of you rightfully might be looking at this and be like, Mr. Brown, you left off some absolute values. That should be the natural log of the absolute value of y. And that should be the natural log of the absolute value of 2x plus 9. And you're right, it should be that. But why on this problem, if you wanted to, could you leave off those absolute values? Because it's greater than 0. Like, there's no chance it's going to be negative anyways, because I told you that. So to save you some time later and not having to worry about the plus or minus, just drop off the absolute value now. Now, if you put them, would you be wrong? Of course not, because the rule does have an absolute value. So then this is the general solution. We do need to get it down to the particular solution. So at this point, I can go ahead and plug in that initial condition. So here's me solving for the initial condition. I have the natural log of y, so the natural log of 1 is equal to negative 1/2 of the natural log of 2 times x, which is 0 plus 9, and we're looking for c. I already saw this one, but it's a common initial condition for a log problem. The natural log of 1 is 0. And so I have 0 is equal to this negative 1/2, natural log of 9 plus c. So c is equal to the 1/2 natural log of 9. And I'm going to leave my answer like that. That's fine. That is my c value. We're not done, but I can leave my c like that. Do want to remind you, though, we do have some properties of logarithms that are good to remember about. For example, we have this rule. When we have a coefficient in front of a logarithm, what can we do with that coefficient? We can make it in the exponent, so I can write as the natural log of a to the c. So yes, that is a constant, but if you had written your constant as the natural log of 9 to the 1/2, that's not wrong. That's still the same thing. You could have gone even further, because raising something to the 1/2 is the same thing as the square root, and the square root of 9 is 3. So you could just say that is your c value. And again, that's probably simpler, but again, it's not necessary. We can still use kind of the ugly one. So finishing out that problem, I am going to use the ugly one just because it didn't really ask us to simplify it. So I have the natural log of y is equal to negative 1/2 natural log of 2x plus 9 plus that c value, which is 1/2 natural log of 9, or natural log of 3, same thing. And then solving this one, we do want to solve it for y. So what do I need to do to both sides to get it in the form of y equals? Base e. So again, remember when you base e, it's super important you remember you're putting everything inside the exponent. Don't base e each individual term. That's some bad algebra. So on the left-hand side, we just have y. And on the right-hand side, we have e to the negative 1/2 natural log of 2x plus 9 plus 1/2 natural log of 9. And then we do want to kind of check to make sure we answer our question. Is this a particular solution? Yep, we solved for the constant. Do we have it in the form of y equals? Yep. Is that a function? Yes, e to anything is going to be a function. Now, if it didn't ask you to simplify your answer, which this one didn't, that answer would be perfectly fine to have. If this was a multiple choice question, though, I can pretty much guarantee that that final answer would not be an actual final answer. So why I actually chose this one is not really for the calculus, although reminding yourself of like u sub and the natural log rules are important. I really chose this one to talk about how we could simplify that final answer. How do I know, just looking at that can be simplified? I see both e and natural log. And I know that when those touch, they can cancel each other out. So I just need to be able to manipulate it until things kind of simplify down all the way. I'm going to go ahead and just copy that answer onto the next slide. And we're going to end today, if it will let me, not really doing any calculus, but actually using their last slide to just talk about the algebra we would use to simplify this answer. Questions, though, on how I solved any of that so far? You're like, no, we're not asking questions. We want to be done. Okay. 5B. So this was the equation that we got. And again, my kind of statement to you is like, that is definitely not going to be an answer choice on the AP exam. How do I know that? Like looking at something like this, I know that there's some simplifying that can happen. Now you can't distribute a base E across. It doesn't work that way mathematically. How we simplify this is we need to simplify what we see in the exponent. So this is what I see in the exponent. And we need to get this as simplified as possible to try to get it to cancel with the base E. So what can we do to simplify it? We already talked about one rule. When we see coefficients, where can those coefficients go? Those coefficients can move up into the exponent. So we could have the natural log of 2x plus 9 to the negative 1/2 plus the natural log of 9 raised to the 1/2. And of course, the natural log of 9, that's of the 1/2 is just going to become the natural log of 3. The other rule we want to remind ourselves of is these are two logarithms being added together. What do we know that we can do with two logarithms of the same base being added together? Multiply. So we have this rule. When you have the natural log of something plus the natural log of something else, you can combine it using a product. There is also a quotient one. If you are subtracting two natural logs, you can combine them using division. And so if I'm simplifying this one, I can write this as a single log of the first one times the inside of the other one, which is 9 to the 1/2, or just 3. And then now I'm going to kind of go back to the problem to simplify. Yes, Evan?
Can you put the 1/2, can we take the 1/2 out at the beginning and then put the natural log of 9 in front?
So yes, there's lots of different routes I could take to do this. So I could have factored out like a 1/2 to begin with. I could even have flipped those terms and it would have been a subtraction instead of addition. You had done a quotient. So yeah, there's going to be still, even with this, lots of different routes you could take to get to the same final thing. I did it this way. So again, when I put it back in the problem, this is e to the natural log, and then we have kind of all of this inside of it. Now that is a single natural log. Now and only now can we simplify it. What's going to happen to that e and the natural log that are touching? They cancel out. What is left over? This 2x plus 9 to the negative 1/2 times 3, or 3 times all that, whatever order you have it in. And probably the answer that would be a choice on the AP exam would be something like 3 over the square root of 2x plus 9. So again, what I want us to kind of look at is how we have this ugly answer and making sure we can kind of identify and see how it matches to the simplified one. Now, if it was a multiple choice question, I think some of you could probably look at those two answers and be able to recognize how they really are the same thing and similar. But if not, there's like the algebra that I did want to review with you, and how we can kind of simplify those problems. Questions on that? All right, well, that is all that I wanted to do today in class. Again, I am not assigning anything over spring break. So there is homework, and again, I'm going to kind of say like, hey, work on it during class time, but once class is over, enjoy your spring break. When we come back after spring break again, we will be on that shortened schedule, but we're going to be looking at some of the special word problems we have with differential equations. We'll be doing that probably Monday and Tuesday. That Wednesday will still be a URL, but we're basically going to start reviewing for the test on Wednesday and then Thursday. And then your test, your last unit test is going to be on the Friday after spring break. At this point, if you're working on stuff, you can do all of homeworks 1, 2, and 4 right now. Can't really do homework number 3. Again, enjoy your spring break, but if you find yourself bored and needing something to do, there's a really nice review tab for the AP exam in OneNote for you to kind of peruse at your, enjoyment. But other than that, that's all I have for class today. Again, I do want you to enjoy your spring break. If you're going anywhere, be safe and be smart.